Welcome to Game On Baby, Build HTML Games with AI. This is a workshop focused on practical skills for customizing, debugging, owning, and teaching games built with AI. Today is different. You will be actively doing, not just watching. By the end of 2 hours, you'll take home 5 tested HTML games, the skill to debug common errors, and a framework for building new games independently. Here is our 2-hour roadmap. We'll start with a game demo, then move to debug and customize, followed by a prompt framework session, and finally, Q&A and resources. Our goal is to leave with 6 HTML files, not just theory. Part 1 is a live demo for 20 minutes. We'll start by seeing all 6 games in action. Game 1 is Pac-Man Vocab. The teacher dashboard allows setting questions, choosing answers, team names, lives, and player mode. It is best for vocabulary review and picture-based questions in a 2-team competitive setting. Game 2 is Fruit Catch. You can target categories, set correct and distractor items, manage time limits and speed, and organize teams. It's great for a warm-up activity for vocabulary or grammar concepts across different age groups. Game 3 is Brain Battle. Paste questions in QABCD format, add a check mark for the correct option, and set a timer with a shuffle option. This is best for grammar quizzes, vocabulary checks, and fast-paced end-of-unit reviews. Game 4 is Sentence Scramble. Enter 1 sentence per line for auto-scrambling. Set up to 4 teams with custom names and use manual scoring buttons. It's perfect for word order, grammar, and sentence structure practice in a team competition. Game 5 is Time Machine. Set up 4 eras with custom icons, names, and question lists using the Q, Question A, Answer Hint format. Use A2Team Circle Fill scoring system for speaking practice organized by grammar era. Game 6 is Spelling Chase. Input word and hint per item, including image paste. Choose solo or 2-player side-by-side mode and adjust speed, HP hearts, and timer settings. It's ideal for spelling practice across all levels. For each game, we'll double-click the HTML file to open it in Chrome, access the teacher dashboard to enter content, play 1 round to observe the mechanics, and then return to the dashboard for a quick content change demo. Part 2 focuses on debugging and customization, lasting 50 minutes. We'll learn to diagnose, fix, and edit the games. A key takeaway is that 90% of game bugs stem from one vague line in the prompt. We'll focus on resolving the most common issues: blank screens, broken buttons, fast timers, and incorrect scores. The F12 console is where we find every bug's address. The 3-step diagnosis is to open the Chrome console, find the red error line, and then copy and paste it along with the surrounding code into Gemini for assistance. This reference card helps recognize and fix 5 common bug types, from white screens and unresponsive buttons to timing issues, score updates, and dashboard settings not saving. Solutions often involve checking function names, clearing intervals, or addressing case sensitivity. Step 3 is writing the right prompt. Do not say, "Fix my game." Say exactly what is wrong. The correct prompt includes the specific symptom and error message and asks to fix only 1 section to keep other code intact. Now, it's time for a 20-minute debug exercise. We'll find and fix 3 planted bugs. Bug 1 is a timer counting too fast. Bug 2 is a broken start button. Bug 3 is a score that never increases. You'll have 5 minutes for each bug. For customization, you need to find specific sections in the code to edit directly. Each game has a dedicated section for updating content, like questions, answers, words, and hints. This allows for quick personalization without relying on AI. This 15-minute hands-on session focuses on customizing 1 game with your class content. First, pick a game. Second, open the dashboard and delete all sample content. Third, enter 8 to 10 items from your current lesson. Fourth, click Start and test 1 full round. We'll now take a 5-minute break. Take time to stretch, grab some water, and check your phone 1 last time. Feel free to use the QR code to join the Zalo group. Welcome to Part 3, the Prompt Framework, a 35-minute session on how to build your own games forever. The 5G framework is a core skill for building games. Every game starts with these 5 questions: goal, genre, game elements, game mechanics, and get out. They structure your prompt for better results. Here's a live demo where a new game is built in 3 minutes using the 5G framework. We fill in the goal, genre, game elements, mechanics, and get out fields with specific details, ensuring a clear prompt. To prevent bugs, follow these 5 rules. Always add technical constraints, describe the teacher dashboard, specify the end screen, make one request per message, and use specific beats for detail. This prevents 80% of bugs. Use the technical constraint boilerplate at the end of every game prompt. This prevents 80% of bugs by requiring a single HTML file, no external libraries, offline functionality, and specific dashboard elements. For the next 15 minutes, write a prompt to build your 7th game using the 5G worksheet. Fill in the goal, genre, game elements, mechanics, and get-out sections with details specific to your class and desired game. In this 5-minute showcase, 3 volunteer teachers will share their new games. They will share their class, topic, the 5G prompt used, and one thing they want to improve about the game. There will be quick feedback and debugging if necessary. Welcome to Part 4, Q&A and Resources, a 15-minute section to help you take everything home and teach using the tools next week. Remember these 3 takeaways. First, use specific prompts to avoid bugs. Second, debug by diagnosing and fixing one section at a time. Third, utilize the 5G framework to build games independently forever. Within 24 hours, you will receive all the deliverables you unlocked today. This includes 5 HTML game files and valuable resources like the Debug Guide PDF, the 5G prompt template, and the Identity Studio Guide. Now it's time for questions and answers. Feel free to ask anything about today's content. We can also do a live debug or screen share if you need assistance. One frequent question is about the timer counting too fast. The buggy code often involves an interval stack. The fix is to declare the timer interval outside the function and use !clear interval before starting a new interval. Games sometimes fail offline due to 5 common causes. To prevent this, include constraints in your prompt. No external CDNs, no API calls, use only system fonts, no ES6 modules, and hardcode all data inside the HTML file. Here is a pre-teaching checklist with 8 steps. Always check that the game loads, shows your content, plays a full round, has a correct timer and score, is tested in the correct browser, is on the desktop, and works offline. Never skip the offline test. Follow this 7-day action plan. Today, copy and test 1 game offline. Day 2, customize and teach 1 game. Day 3-4, use it in class and note improvements. Day 5-6, debug and customize a 2nd game. Day 7, share your success in the Zalo group. Community is vital. Join the Zalo group, Game on Baby Lab, to share games, debug together, participate in weekly challenges, get support, and access the growing game vault and prompt library. You do not need to wait for AI to get smarter to build games. You have everything you need right now to create engaging learning experiences. That is what this video was all about. The workshop is complete. You are taking home 6 HTML games, debug skills, the 5G framework, and Zalo community access. Copy your files, join the Zalo group, and share your commitment with a colleague right now.